Okay. Okay, I got the audio. Awesome, awesome. So, how's everyone doing? Today, yes.
Can you full screen that?
Can I full screen it?
Yeah. Like, is there a button on your computer that you can full screen? I think it's like F12, no?
F11.
Oh.
F11.
Oh, nice. Thanks.
Is it still okay? Still being doing that. Okay. So what's up, guys? Today we're going to delete the middle node of a linked list. So, any ideas?
You probably have to make a pointer to the header.
You could do that. So what? Like cur equals head.
Yeah.
Okay, then what?
With assuming you're gonna iterate until you get to that node you gotta delete.
Till you get to the end.
No, it's like no, so you gotta delete. Maybe like skip it over, connect four to one. At least an example.
4 to 1. Okay, but how do we know when if 4 is the one right before the middle?
To brute force it, could you theoretically like go through the entire list, count how many nodes there are, and then go back to the beginning and then go again with the halfway, and then when you're about to reach the halfway point, instead of going to the next one, you do what he said and go like skip over two.
Oh, you skip over 2 in the word. It's like 4.
Yeah, like for example, when you get to four, you know that the next one is gonna be three, so then you skip over to one.
Okay.
And then you keep going.
All right. Okay, so I got some pretty good ideas. So we're gonna get the size is 0, right? If walker size plus equal 1, right? And then we go to the next one. Equals cur dot next. Okay, and then we have a size by that point. So then we have to start from the beginning, right? And then what?
So now you have size.
Right.
Then do size divided. Actually, do wild. Yeah, size divided by two.
Mm-hmm.
Then you do. You start another count.
Okay.
Yes.
So a count. So where do we go? Do we start at 0 or
Yeah. And then you go again until the count is less than the middle. And then you just do. You're returning our linked list, right?
I'm returning a list node. If you return the head, you're pretty much returning the linked list.
Okay, so you have to make a modified one. So you have to make another list.
Well, if you have,
I don't know. I don't know too much about linked lists. I don't know if you can like modify them.
I don't think you need to modify it. Do you? Can we modify it?
no, I mean, this returns the head of a linked list. So the head is a node. So you're returning a node. So all we need to do is just modify the pointers so that we have the middle deleted. Yo.
Is that thing on?
Yeah, but I don't think. Oh, they did see that. All right, it doesn't matter. Actually, before we continue, let me see something. Is this? Oh, that's 11. Oh, okay, they can see it. Just making sure they can see it. Okay, they can see it. All right. So what deleting the middle of the linked list. What should we do? Right? We got the size. We got the middle value. We have a counter I. We start at 0. So while I is less than the mid, we do that. And then what?
You just have the last next to the
current dot next next. Mm. So current equals what?
Current dot next. Oh no, dot next dot next.
Yeah, that was a mistake. And then we just return the head, right? So let's just run it, see how it goes. Wrong. What do we return? We did not. Turns out we did not really change it.
We did it. We just returned what we put it.
Oh wait, current next. Okay, there we go. I actually meant to do that. So wrong answer. It turns out we deleted 1 instead of 7.
Okay, so then I guess well, I is less than bid minus 1.
Okay. 1 4. Right. Okay.
No.
All right.
There is no next because it is only 1.
So actually, we do need to check for something. So if it's just so I guess if cur and cur dot next, right? Why am I doing that? Why am I doing that? Yeah, you can actually get the attributes of a non-null variable. Make sense? That again.
But that'll still give us an error, right? Because it's still trying to.
Yeah. So what's up, Demba?
In this solution, I think like if it's like let's say another language, you might probably have some memory leakage because the 7 is not like the one you deleted. You're not really deleting it because it's still pointing to something. You know what I mean? Like in that like current that next, it's now pointing to current that next right? But
Yeah.
that current that next, there's no pointer that goes to it, but it still has a pointer that is pointing to like current that next. You see what I'm saying?
You want a free memory? Okay. So I guess
But
with
then you only have the one pointer.
Pointing to the other things.
Like the extra memory is not the whole list to the end. It's only the one pointer. So
Even though that one pointer points
Yeah.
to the next 7,
Yeah.
it's still just that one.
because the pointers just point to memory.
Yeah.
They're not actually storing the whole memory themselves.
it's just like one extra memory,
One extra list is node.
one node.
Yeah, it's just gonna be that
Okay.
one extra. Wait, I think it's safer to just delete it. You take that one extra out.
You can delete. It's not. It's big if you're creating a bunch of pointers constantly. Then you run into some memory issues.
So what's one extra check that in this particular problem? I'm sorry. Well, talking about memory leakage. So what can we do? Because we ended up returning something, but we're supposed to return an empty null.
Maybe we
Like
can
list.
put if current is equal to or if current dot next is equal to null, then delete the.
So we could do it at the very beginning, right? If it's only 1, you would delete that 1, right?
Yes.
So if head dot not head or not head dot next return none. Yeah, it's just a null list node. You got that? All right. Can we optimize this somehow, some way? Do we need 2 while loops? Do you need the length? Do you need to know the length to get the middle? Do you need to know the length to get the middle? Philosophical question. A little bit. The middle is the middle node of the whole list. Okay, well, I'm asking philosophical questions with implications. Do you really need to know the length of this link? Let's forget about deleting. Just to find the middle node, do we really need to know the length? Just finding it.
No.
Okay, he said the answer. So if we don't need to do that, then, well, then how do we know whether we're at the middle? Any ideas? Without size, without this. I'll just delete everything for now. One while loop. You only need one while loop to do this. It was, Lazaro, it was Floyd, right?
Huh?
It was Floyd, right?
Floyd what?
That invented this algorithm I know to use
What are you talking about?
to get the middle of a linked list.
Oh yeah.
It's Floyd.
Wait, doesn't that only work for cycles, Floyd?
Yeah, kinda. But if you have one fast and slow pointer, what does that tell you?
The fast one gets to end before the slow one.
Yeah.
Where would the slow one stop?
It would stop in the middle. Wait, no. Oh, I see.
So exactly. This Floyd's, well, it's a cycle detection. Well, it's not really cycle detection. You can use it for cycle detection, that's for sure. But do I have to move that?
If you do, I'll just point at you.
Okay. All right. Do you guys want me to draw it out? Or do you want me to just put it on?
I guess you draw for him.
Okay, so I'm gonna draw it out.
I'll take care of it.
Oh, it's following me.
It's all
Oh,
right.
it is.
Oh, you don't want to be in the. You don't want to be in it?
So we're gonna have fast and slow. We'll start here, right? Then what? So if we have something moving twice as fast as something else, right? And a certain amount of time passes. So let's say you have a car that's going on 10 miles per hour, one going 20. In an hour, how much will the slow car go? And then the other one? So it's twice. What is half the list?
That's where the slow pointer stops out when the fast one gets to the middle.
The fast one gets to the end.
Yeah.
So that means that the fast one got the whole length, and the slow is right in the middle, because the middle is just half of the whole thing. So we move the slow up by 1, and the fast move it by 2. Right? And while slow is still good, while fast is still not null, while this next of fast is not null. Right? So move fast 2. And I stop. Okay. So I stop here. Why do I stop here? Because there's no next in fast. also one other thing. While we have slow, while slow was here, I'm gonna have previous being before slow. And every time I move slow up by one, I move previous up by one. So previous is going to end up here. Okay?
So that you can have appointments moved from the previous.
Right. So then I say that the previous next is this. I have it like that.
That's great.
And we cut out the middle. So let's do another one. I'm gonna do one that's even size. 4, that's good. Previous and fast. Right? So remove. And well, actually, how did I think about it? I think I moved this one up too much. Fast is here and move it here, right? Fast still on the next one, so I can move fast here, here, and put previous here, right? And so I just do this, right? And it still works. Do we get the point of the fast and slow pointer? That's Floyd cycle detection works here too. All good? We get it? Any questions about it? So, so what about here? So how does it work now?
When it goes fast, that's when you know also.
So we don't do anything, right?
Yeah.
So what's the middle of that one?
That would be
That.
itself, so you're moving.
Well, since we're returning a node and it was just itself, return no, just return no. That's still not what we're gonna return.
Cool.
So why don't we get that solution now? Just, you move this like right over here.
What's up, Joseph? How you doing? You guys running a bit late?
So if I have to get up there. Okay. So we don't need this at all, actually. We could, but we're not gonna do that. So what do we say? We had to keep track of what? Previous, slow and fast. We said previous was the one before the first one, the head, so it's none. Slow is the head. Fast is the head. Do we understand how that works? How this one is set to the first one here, this one is set to this one here, this one is set to this one here. Okay, we're not lost on that. Good. So while slow and fast dot next, right? That's what we said before. We need to make sure that fast has the next one. Previous is going to equal to slow. Slow is going to be the slow dot next. And fast equals to fast dot next. Because it goes twice as fast as slow. Okay, so we want to check if there's only one, right? If there's only one, then there was no fast dot next, and fast and slow are the same. So if fast is equal to slow, what? Yeah, in this case, it's none. All right, so the next thing you do, right? Previous is the one right before the middle, right? The one where slow ends. So we just say prev dot next equals slow, the middle, dot next. So prev next doesn't point to slow anymore. It points to the one after slow. Slow being the middle. Right.
Whoa, that's still a lot of time. Then.
Well, sure. It's a little faster, but we only had to do one while loop, right? And actually, the while loop did it in half the time as the first while loop we did, which was the whole thing. So it's more efficient. Yeah.
You have to check for slow. Since, I mean,
That's a good
slow.
point. Since fast is
Yeah,
like
do you have to
slow.
check for slow? To slow?
Do I have to check slow?
Yeah.
Yeah,
While
no,
slow.
Code nine,
While
code
s-
line nine.
You don't necessarily have to do while slow, right?
Because they start at the same time.
I mean, I guess, but I'll just put it. We'll just put it. I mean, okay.
Take it out, see how it works. How it affects it.
I think it just still run.
Oh, yeah,
It'll run,
it
yeah,
does
it'll run.
Would it help out a little bit?
Oh.
It does help out time.
No, I mean that's good time.
About the same, yeah.
No, it's an improvement. I mean, technically, yeah. If both slow are equal, fast and slow are equal to each other, it could be that they're both ahead or they're both null. So that's this check right here. So return null. Okay. So we did this one. What's the next one we're supposed to do?
What's the fastest we can go?
I actually don't know. For Python code, I'm not really sure.
Apparently like 60% of people
Mm,
do it faster.
yes, but well, I think it's more like 58%. But who's being accurate? Move node. Move and nope, not do. Okay, we'll just do this one then. No, yeah, I'm not doing it. I'm not doing it. No.
If you have any questions, maybe you go to a similar tag, you might see something you like.
What?
Like there's a tag down that shows you similar questions.
Back.
Like in the problem description itself.
Yeah, I'm going back to the problem. Back to the problem. Back to the problem. Similar questions. Okay, yeah, but not this one. Oh, okay, look. Middle of linked list, we already did that. Or maybe I should have started with that one. I should have started with that one, but that's fine. Okay, so now we're going to remove linked list elements. Okay. So we have the head, which is the first node, and then we have a value that we want to prune every node that contains that value from the linked list. What do we do?
That's what we use exploiting.
Do that except just as with previous instead of a fact.
No, we're not. We don't need to use that at all. Well, why don't we start off with the. Let's say we have a continuous stream of vowels. Say vowel is 1. What do we do? What if the first node has that value? What do we do?
We have actually two, kind of like 2 pointers, right? And then one would be ahead, and then you remove the one previous if it's matching at the target number.
Well, I mean, we have head as a node, right?
Yeah.
So what if we just move head up 1 every time that head is the value? So what about this? Well, head and head dot value equals value head equals head dot next, right? Okay. So then head goes to the first value where it's not that value. Make sense? Okay. So then what do we do next? So we could do like a, pointer, right? So we can just do like that. Occur, right? So while occur, well, we could do like a temporary node, right? How did you guys figure it out? So what do you think we should do? Yeah, removing linked list elements.
I have a question though, but if you're doing the head and head dot is equal to val, wouldn't it only run if the value of the linked list is that?
Well, if the head is that value, we want to make head point to the next one. So I have to prune it. You want to get rid of every starting value, every starting node that has that value.
Yeah, but then the head itself is that value. So you have to do it only before, right?
So
If the head is the value, let's say one was the value, then you start from two. Two is gonna be the head.
Yeah, but when you said that the oh no, maybe it's just like I'm looking at
I don't think he is implemented.
actually, you know what? If I'll just
you can spread it back there behind the
yeah, I could just do that. I'll just do that instead.
Wait, you can spread it if the head is the value you want to remove? Yeah.
Let me. Okay, there we go. Okay, transition. So this part that I'm doing. So let me make it stop. No, it doesn't do that. So let's say our value is 6. I don't know. And let's say this is our head. Right? So this is the value we want to remove. So what if we just move the head up by 1?
Oh, I see what you're doing.
And just do it until we're here.
I mean, that's assuming you get a bunch of like the values at the beginning.
I mean, it could be 1, but it's still going to end where it stops being that value.
Yeah.
Let me just make sure you see that. You do see why that's the point, right?
Yeah.
You guys understand?
Yeah.
Okay, so that's why we start out that way. Let me go back to this. So now what do we do next? So we got all the way to where it stopped being it, or it's null. Could be null. So what do we do?
We probably make a temp node equal to current.
Okay. Temp equal current. And then what?
And then if current is equal to the target node you want to root, then equal temp to current on next.
We could do that. Curve. Any ideas?
Huh?
Any ideas?
What?
How to do this?
Can't you just check 1 forward? Move the init. And see if that's if 1 forward is a node and that node's value is equal to target.
Like that?
It's not even a problem.
But you have like a previous value that follows it, and if it's equal to the value that you want to do, just move the previous value to be the next and that.
Right.
Go through the whole list.
So right now, curve, the value of curve shouldn't be val, right? So you could do temp equals curve on next, right? And just check val temp and temp dot val. Kind of like what we were doing up there, right? And then say cur dot next equals temp equals cur dot next. That's my idea, at least. What do you think of that? Just looking at it, does it look like it makes sense? Yeah? If we had to return anything, it would have to be what? Right, the head, right? Could be no. No. Okay. Let's accept it. Let's submit it and see if it works. Thank you. But do you see why? Right? So if we didn't do this at first, it wouldn't have worked. And you see why that is. It's all in. Yeah, it's all in. We're going through all the values. Yeah. Okay. Just once. We're going through all the values just once. See if any other questions. Recursion. Oh, we didn't even use recursion. Delete node linked list. Well, we already deleted the middle. We will already know how to delete a node, right? Or maybe you want to refresh. You feel like you need it? We'll just do it. We'll just do it.
What was the first problem? Was delete the middle?
Yeah, delete the middle node.
I also saw another question that delete
Delete element? I don't think it's a linked list. So we're gonna just look at this and this. Danny said he needs. So we're gonna look at this and we're gonna see that it has a very high dislike ratio. Can you guess why?
Oh, you're not giving the header a node.
You're not giving access to that. Then you'll be given access to the node to be deleted directly. Well, that's something.
Oh, that's like the question Danny told us.
Is this the question?
Yeah, that definitely is the
Kind of
question.
funny. But
What?
damn.
How do you even modify node in place instead?
Oh my god. I see what it says now.
Is it just node?
You change the value of the node. you change the value of the node and you make it the next pointer equal to next dot next.
So like you just shift everywhere,
Yeah.
right?
So node equals node dot next. Is that what?
Node.val is equal to node.next.val.
So you're
That's the first thing
technically not like deleting it.
Yeah, you're not deleting it. You're just updating the value in the pointer.
Equals node. Per.
No, I don't think you
No?
You just do node.val.
Oh wait, the node is a pointer anyway.
And this is guaranteed not to be a tail node, so you don't have to worry about
Yeah.
it.
And then node.next is equal to node.next.next.
So basically, you're just overwriting this with this value
Yeah.
in the pointer.
Yeah.
It's not even the fastest.
Wait, that's what he was asked at OA?
I'm not sure, but that I think.
Yo, why wasn't I asked that question? I got a really hard question. Okay, do you guys want to do something?
Node equals node dot next.
Node equals node.next?
Yeah. Would that work?
Yeah, that one still has a value regardless.
That
If you just put node
okay.
equals node dot next, would that work?
that wouldn't change, but that would okay, but that would
I mean, I feel like it would, the value's gonna be the same.
Wait, but would it change the pointer of its parent?
this is not gonna work.
I don't think so.
It's not gonna work. The reason it's not gonna work because technically a reference itself is a value, and you're passing that reference by value. So you're not really changing the data structure. Does that make sense? Yeah. So yeah, no, you do need to do what we just did before, and you guys want to go off topic. Would you guys like to go off topic?
Can we see the submissions to see what's the fastest way this is done?
Discuss. It's literally just that. It's literally just that.
Oh, one line solution.
Yeah, they're all just the same. They're all
But
just
then
the same.
How is it like?
I don't know. Sometimes it's just different. Alright. You guys want to go off topic? Very far off topic. Off the road into a harder problem that has nothing to do. Can I go off topic?
Down the canyon to a stream.
If they want to go.
I mean, so
Drowning under rocks.
Real off topic.
What harder problem do you need?
It's well, I want to do stimulus one.
Don't do the rumble.
No, not the Rumbas. Candy Crush. Hmm?
Maybe do a question like a review question from last week. What did you guys cover last week?
No, we didn't. What did we cover that? What?
Queries?
Not queries, but like intervals.
Oh,
like
right.
Yeah, the meter runs questions.
Let me move. Meeting rooms. Oh, that's what we went over. Meeting rooms 2. No. You should. Okay, no, this isn't the answer. I was scared. That's not the answer, guys.
I thought we did this already.
We did. Do you remember how to do it?
I mean, I think I know the overall approach.
What's the approach?
You first I'll get to sort it. Is it
Sort what?
Sort it by the start times.
The what?
No, the meetings by the start times.
That's not exactly what we have to do. Yeah, see? Maybe we should do reviews.
Wait, didn't you do this problem?
Hmm?
Was this the problem you did?
I did this one.
Okay.
This was the second one that I did.
Why not do another linked list?
We did 3. I don't know. I don't want to. I want to
Two of
leave.
them were easy. Give them a medium.
We did a
Yeah.
we did one again.
I don't want to, because then Joseph's gonna like go over the hard ones. I don't want to. You know, there's not that many hard. There's not that many hard problems.
Yeah, cycling section.
Okay.
Do the one
That's basically what I just told you.
Yeah,
Actually, what's the name of this problem?
Oh yeah.
Trying to think about that problem where it is tortoise in the hair, but it's with indices of an array. I think you know what I'm talking about. You know what I'm talking about.
Yeah.
What's
I've seen
that?
problem.
What's the name of that one?
But that's an array. That's not.
I think I've saw them actually.
But let's just duplicates, right? A tree? We could do that. Oh, contains duplicate? No, hard. The what?
Oh, that's a good problem.
Which one? Which one?
Two numbers.
Difference between two numbers?
Addition.
Oh, adding two numbers. Okay, okay, okay. Yeah. Add two numbers, right? This one?
I think add two problems to it. Oh, I remember this problem.
All right, guys. So wait, is it strings or they have numbers in the as the vowels?
No.
It's actual ins.
It's like the list.
Okay, okay, okay. All right, guys. So the linked list is a number in reverse order. All right, and they're both non-empty. So return the sum as a linked list.
So enter reverse the link list and then add.
No. We don't have to reverse anything. It's already reversed. Well, right now, yeah, right now we don't have to do anything. Okay. All right, guys. Tell me what you want to hint.
Are we using employees by any chance?
No, we don't need that at all.
Okay,
We're adding two numbers. Actually, while we're here, who knows? Who remembers how to add numbers? I would hope. Let me erase this.
1 + 1.
5. Or 2.
3.
Okay. What's this problem? 465. Oh, let me just check if they can see it. If stream can see it too. It might be a little too hard because it's in the shadow. 342. How do we add numbers? Right, these are in the right hand side. I mean, here it's reversed, but let's just say this is the beginning of the note. Right, so we do 5 + 2. So that would be like this note of our answer, right? So, do we have to do anything? We have to keep track of anything else that we're adding?
I guess anything that carries over to the next
Right. So what's the carry for this one?
0.
Actually, should there have been carry before?
I don't think so.
Why not? What will be the carry at the very beginning?
Oh, it'll be 0.
Carry will be 0 at the very beginning. Maybe that'll give you. Maybe this will give you an idea. Okay, so then we add these three. What do we get?
10, so 1 will be the carryover.
Right. Again, that's 8.
Shoot, I just remember that this was introduced over.
Yeah.
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 Oh, dang.
Do you see the steps we have to take? What's the steps we have to take?
We have to have a variable called carry.
Mm-hmm. Okay. Good. We need a carry. Keep track of that. And we have to go through them, right? Through the list. L1 or L2 or carry. Okay. Actually, while I'm on that, let's make a dummy. Dummy equals. We're gonna make a new list node. It could be whatever you want. This is probably not even necessary, but I'm just gonna make it this. It equals dummy. All right. So our carry is 0, and we're iterating through L1 and L2. So what do we do, right? We get num is equal to what? Right? Okay. So we get an answer. The answer could be what? Yeah, it could be 10 or higher. So I guess another important thing is that these are digits. So every number in each node is going to be at most 1 digit. So they're all less than 10. No, we can't have 10. We can't have 11 as a value in each node because each node is supposed to represent a digit. So num equals L1.val plus L2.val. Okay? But it's not just that. We're missing a step. What are we missing? We're adding the value from list 1 and 2 and no. The carry. We have to add the carry. Okay? By the way, this is going to be buggy at first, and I know, but we're going to debug together. We'll get to that. So we get the number, right? So we're going to do it dot next equals, we're going to make a new list node, right? List node. It's going to be mod 10. You're right. You want the digit on the other side. And then carry is going to be equal to carry divided by 10. Why divided by 10? Yeah, we're dropping the last decimal. And since it's just 1 digit, the most you're gonna get either 1 or 0.
You know, I want to ask, it's 2 slashes, right?
Actually, now that I think about it, actually no, I'll leave it like that. What's up?
No, would it be 2 slashes for line 14?
Yeah. This is fine. Okay, so what do I do? L1 equals L1 dot next, right? L2 equals L2. L2 equals L2 dot next. And it equals it dot next. Return dummy next. Am I going to get a problem? Well, no, it'll end. I got a problem. 708. All right. We got 707 instead of 708. It's kind of weird. Why did they expect 708?
Well, because it's like reversed.
You missed the carry. Yeah.
The carry.
No, a carry is 0 by start.
Okay, 5 plus 2, that's your 7, right? So that's be your last digit if it were like a string.
Mm-hmm.
And then 6 plus 4, that's 10, right? So you missed that one carry. Yeah. That's why you have a 7 instead of 8.
Hold on.
Okay.
Is this
carry divided by 10? Should it be modulo 10?
no, because we want to.
No, it is divided by 10.
It's divided by 10.
No, it's modulo 10. Carry is modulo 10.
All right, guys, debate.
No, carry is divided by 10.
Because I'm on the side of divide, and we add.
Carry would be divided by 10.
Wait, yeah.
Wait, no, it's not carry. You did carry equals carry divided by 10. It'd be num divided by 10.
Oh.
Okay, there we go.
Oopsies. Didn't even notice that mistake. All right. This is gonna give me a problem. Yes, it did. It gave me a problem.
Oh my gosh.
Okay, I'm missing something. Thank you. So, what's the problem? Just check it. Really,
They're not the same length.
it could not be the same length. So L1 might be null, and L2 is, right? So, if L1, well, we could just say num 0. L1 num plus equal and 1 dot val. Makes sense, right? If L2 num plus equal L2 dot val. Num plus equal carry. We can get rid of this. We could do this too. We can actually put this here. Okay, on again. Submit.
My God.
Yo.
All right. I wish this was the question I got last night, bro.
What question you get?
Well, I got one that was like pup the bubble. Pup. Got my Latin accent there. Pup the bubble.
Did you sign
Pop.
an NDA?
Yeah. Okay, I won't say too much. But it wasn't as easy as this one.
Do the second one. Do it. Add 2 numbers too.
Add 2 numbers too.
Oh, no, that's right. This one.
So it's not in reverse order this time.
Yeah, exactly.
Okay. You know what? Okay.
The way to solve for this is, I think you will think about it, reverse it and solve the top level, or do it recursively. Recursively is the right solution. Because if you do it recursively, you can do the last node. Because since the carry affects, since it's no longer in reverse, the carry affects the parent, right, of a node. So if you do it recursively, you can solve this, the last digit and then return that carry to the parent. So that's why recursion is the best option for this problem.
This is stack.
Just trust. Well, recursion is a stack.
Oh, yeah.
This is stack. This is right. This is stack.
Okay. I haven't encountered this problem yet, so be good for me too. Add 2 numbers 2. So what do you say we had to do?
Do recursively, like iterate the function recursively. And I think if there are different lengths, you want to pad them with zeros first.
So we had to find the lengths.
Either, yeah, I think so.
Not necessarily.
It's still not reversible. No matter whether you do it recursively or not, it's still will be the same complex as your.
Yeah, it will be the same time. But if you do it recursively, so it's gonna be. But I guess it's still because you're gonna go and you're gonna return this last. So it's still.
If you don't pad it, then you know the one that's bigger. Don't do anything with those digits until you get to a place where it is affected. But you need to know when you actually start adding the values of each node. And padding it makes that really easier.
Yeah, of course it does. Like I know it does. Like what I was thinking is, like it doesn't matter anymore because even if you do it recursively, you're gonna have to like start from 7 with the four and 2 with the 4 and the 4 and 3 and then you're gonna turn back 4, 2, and 7, right? That is the same thing, right? Like then you don't get any efficiency by doing that. You reverse it as well because if you were to reverse it, it will still be a singular traversal from 7 to 2 to 4 to 3 and then 1 back and then that's it. Voila. So it's essentially the same thing. Like the recursive solution doesn't have any edge over.
No, yeah. You can do both perfectly fine. It's just recursion is like the nicer solution. It's not like the more optimal in every way.
I'm just gonna reverse them.
Okay.
And then reverse my answer, and that's it. I'm gonna
reverse it and then just copy it.
Yes, yes. Reverse it. Reverse it. Okay. What was I gonna do? Right.
Reverse it. I remember doing this during those 14 days, and I was doing the first one, and I thought I had to reverse the first one, so I was trying to do like adding two numbers one, but like without utilizing the reversing aspect of it. So like I put it back to how it looks here, and then I transformed it like that.
Yeah, I think we did send out this file before.
Is that how you reverse the linked list? Joseph says yes. Does Lazaro have anything to say, or no? You don't want to? Almost made that. Actually, you probably don't even need to specify if it's curl one or that. Actually, no, prep one. That actually makes sense. I'll just keep it like that. It's just two of them. He's lying. Okay. no, put self there. That's important. What is what? Self dot reverse the one. Right? And then yeah. Yeah. Yeah, there we go. Okay, hold on. Ah, yes, I did mean that. Sorry. Carry. Ah, right. So is this right? This is not right. Why is it not right? So I reversed it, right? And then I did the added. But what did the other one return?
You didn't reverse the reverse.
Yes, I need to reverse the answer. Okay, just trying to make this interactive. You know. Okay, so reverse that. Yeah. Reverse. Self dot reverse. Reverse. Dummy dot next. Yeah, that's it. Make sense? Okay. Now I want to go off topic like I wanted. And I want to give you problems. Combination sum. Okay, combination. Yes. Okay. So, there's the answer. You got it? Okay.
Okay, cool.
Okay, there. All right. So basically, you're gonna have a numbered target. You're gonna have a list of numbers candidates. What you're gonna want to do is you want to return all the different possible configurations, right, of collections of each, candidate numbers that they add up to the target. So let's say your target is 7, right? So you get 2, 2, 3. All that is 7. Then you have 7 by itself. That's also another one. You count all those different combinations. Well, actually, to be more precise, you return all of those combinations. The list of all those combinations. Does that make sense? The task is? We have 5 minutes. Do you think we can do this in 5 minutes? Huh? So it's less than 30. Equal to 30. The number of candidate numbers. The candidate numbers go from 1 to 200. All the elements are distinct, and the target is at most 500. Greater than 1. Equal to 1. The positive number is 1 to 500. That's the target. What kind of problem is this? You could, yeah, I did use hashing. But now that I think about it, no, hashing seems, yeah, you may need to use hashing, but it's not just hashing. Something else. What's a B? Buoy? Buoy. Baba Booey. Do we agree with Baba Booey? Right, it's a boomer meme. You don't get it. Okay. Huh? Babadoo? Bibbidi bobbidi boo. It's backtracking. I'll just say it, right? What is backtracking? Who's heard of it? So let's say you want to build out a solution, right? So you built out a solution, but let's say from the previous step, you have other steps too. So you want to backtrack and take the other route. Does that make sense? So it's sort of like DFS, right? Let's say you built out a solution by going down the route. But then you want to go back and using that same route that you've taken before, add on to that in another recursive call. Does that make sense? Yeah, you could say that. You're building out a solution. The further down you go. And once you find the solution, you add it to your list of possible answers. Okay? This one, combination sum, and n queens, which is a hard. Let me see if this is a. Oh, okay, it's free. Good. So n queens is also another backtracking solution. So yeah, actually, let me revert. You don't see it. Who's seen this problem before? Okay, you've seen it?
Yeah.
You've seen it too. Joseph? You never solved it? Well,
But I know how to solve
you know how to solve it. How do you solve it?
it. You need to like do backtracking and check if the state is valid.
Right. Right. So you want to return all the possible configurations given your n being the size of the board, n by n. Right? You want to say, what are all the configurations that the queens can fit on the board such that they don't threaten each other? Do we get the goal? So do the queens threaten each other? Actually, what do we know about chess? Up, down, left, right, diagonal. Okay. So here they don't threaten each other, and here too. So you have to return these two outcomes. So you return it like this. So one solution would be the queen being here in the spot, then the next one in this spot, kind of like this. And then you return the next solution, which is this one. Right? Make sense? How do you do that? How do you build out what's a suitable state? That's the backtracking part. Ricky, you know how to build out.
Yeah.
Yeah? Give him like a little hint.
All right, we have to find a way to efficiently keep track of the state of the queens. How would we do that? What information do we need to store about the queen's position that will help us? Well, obviously we know that they go all the way up, all the way down, left, right, diagonally. But do we have to store the whole grid as a state? Why not?
Just suppositions they move in. Other ones aren't really necessary. This is not going to traverse to them, so.
I would probably recommend you go over like what is backtracking specifically and what the recursive steps are, like the recursion tree, to help people visualize that.
Yeah. So I'll give you guys a hint. So what we know, right, is that so a queen can occupy this row. Can another queen occupy that row? No, of course not, right? But we also have to keep track of one thing. What do we have to keep track of to make sure that the next queen in the next row is in a suitable position? right, and not in the same column.
Yeah.
How do we do that? How do we do that? That's actually the solution right there. How do we make sure? Well, we're gonna do it recursively, but when we're gonna pass in recursively, is a build of all the columns that are filled. Right? Does that make sense? I feel like maybe. So, not just the columns, right? Something more. Okay, what are the diagonals for this one that are filled? Well, it can't be in this or here, right? So how do you give this a name or this a name? Actually, you know what? I think the class is about to start.
There's a class.
I remember today's Tuesday, right? So their class is now. Okay, so it's like UML. Yeah. Anyway, think about this. Pretty good problem. And I'll see you guys tomorrow.